All right, so now that you found those, let's go through them and see how you did on those. So to find so let's go ahead and see if we can figure out the determinant here. So -3, 7, 1, -4. So remember to find the determinant here, you multiply AD, so that's -3 times -4 minus 7 times 1. So we end up getting 12 minus 7, which gives us a value of 5. So therefore, we know that the inverse exists. So now let's go ahead and actually find the inverse. So if you remember how we do this, basically you got A, B, C, D, and then 1 over AD minus BC. And then we're supposed to go ahead and swap the A and the D. So I swap those, and then, oops, it's supposed to be an A. And then after we've done that, then this becomes the opposite, and this becomes the opposite. So let's find that. So it's going to be 1 over AD minus BC, which is exactly what this is, AD minus BC. That's the determinant. We found that to be 5. And then over here in our original matrix there, we're supposed to swap the D and the A there, so that becomes -4, -3. I'm supposed to do the opposite there of 1 and 7, so this is -7, this is -1. So we actually now go ahead and distribute the 1/5 through there, and we end up getting -4/5, and we get a -7/5, and we get a -1/5, and we get a -3/5. So there is our inverse matrix. And I'm not going to do letter D over there, just C. So I want to do this table here. We're supposed to go ahead and use a table below to assign a number to each letter in the message go, and then there's an underscore tonight. Well, if you look at this table of values in here, each of those letters and even the underscore over here has a value. The underscore here is 0, A is worth 1, B is 2, C is 3. And there's lots of places in life where they've done like coded messages. I mean, like communications between armies are coded so that the enemy doesn't be able to intercept messages. So, and just for fun, sometimes just people do this as well, just to be kind of fun with that. So let's see if we can figure out, convert the message to numbers using the table. So we're just supposed to make up a code here. So let's go ahead and let's do go tonight here. So G there is a 7. O here is 15. Underscored is a 0. T there is 20. O there is 15. N has a value from the table there of 14. I from the table there has a 9. G from the table has a 7. H from the table has an 8. And T has a value of 20. All right, it says we're going to code it with a matrix of 2, 1, 4, 3. So we're going to multiply that. So be able to multiply this, remember this matrix A here is a 2 by 2. So we need to have, this one here has got 2 rows and 2 columns. In order for it to match, we need to have a matrix over here that has 2 columns. And this exactly what it says write the message in matrix form, arrange the numbers in a matrix with 2 columns and as many rows as needed. So how many, if we got 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to have 5 rows and 2 columns to be able to do this message. So let's do this. So we got a 5 by 2 and we're going to multiply by a 2 by 2. So putting the numbers in there, 7, 15, 0, 20, and I'm just wrapping them around as I go because of the way to fit it on here. That's 3. So then we got 9, 7, and we've got 8 and 20. So then it says multiply the message there by matrix, multiply the 2 matrices here together in order to make it a coded message so someone looking at it would be able to figure out what it was right away. So we're kind of coding this message so someone would not know that to go tonight. All right, so we can multiply them together. We can go 7 times 2 here is 14, plus 15 times 4 here. So that's row 1, column 1, which gives us 60. And then I can do row 1 here and column 2 over here. So I've got 7 plus 45. Remember, we're going to end up with a 5 by 2 here because that's what's on the outsides here. So then we got row 2 times column 1 there. So we get 0 plus 80. And now I've got row 2, column 2. So I'm going to get 0 plus 60. I'm going to keep going. Row 3 times column 1 there is 30 plus 56. And then I've got row 3, column 2 over there. So I've got 15 plus 14 times 3 there is 42. I'm running out of a little space here. Let me extend this down a little bit. There. So now I'm on row 4, column 1 there. So 9 times 2 there is 18, plus 7 times 2 there is 28. And now I've got row 4 and column 2. So you got 9 times 1 there's 9, plus 7 times 3 there's 21. And then my last one here, 8 times 2 there's 16, plus 20 times 4 there's 80. And then last row in the last column, 8 times 1 there's 8, plus 2 times 3 there's 60. So if now we add those together, we end up with 74. 7 plus 45 there is 52. 0 plus 80 there is 80. 0 plus 60 there is 60. We've got 30 plus 56 there is 86. 15 plus 42 there is 57. We got another row here now. 18 plus 28 there gives us a 46. And then we've got 9 plus 21 there is 30. And then our last row there, 16 plus 80 there is 96. And 8 plus 60 there is a 68. So that would be our coded message, and we could write it out. So we could go 74 slash 52 slash 80 plus 60 slash 86 slash 57 46 slash 30 slash 96 slash 68. That would be our coded message to say go tonight. G-O. No one would know that by, given that that's what we just did. We just multiplied by a simple matrix there. So, and that's what our coded message there would mean to send something like that out. So you get to work on the 4-4 worksheet.